Thanks so much, Lance, and good morning and good afternoon, everyone, and thanks for joining. This is actually the second in our series on DCI, Data Center Interconnect, and I'm joined today with Philip Correa, and together we're going to walk through the different deployment model options for DCI. And I think you're going to find this webinar really interesting. There really are multiple ways to skin the cat when it comes to DCI, and we plan to go through the multiple options, and we're going to talk about this both from a qualitative as well as a financial perspective, really giving you and your customers all the tools in your toolkit to help you make that correct, that optimum deployment model for your DCI deployment. So let's get right into it. Take a bit of a step back. If we look at last time, we focused a lot on the drivers for DCI, and no shortage of charts to talk about artificial intelligence, AI, as being a big driver of that. And every time I see some new analyst report, it really shows all the use cases that AI is doing. And I thought I would share this chart. This is from one of our analysts we work with at Omdia, and he really looked at this from a network perspective. Right? We all see what AI is doing in our day-to-day work lives, but what is this doing on the network? And we'll kind of talk about that. But what I really liked about this quote is it really shows that AI is really now becoming a new inflection point, similar to really back when the internet was introduced back around 2000, right? And we saw the huge build out in that time. And we're kind of seeing the expectation is that AI is going to drive another big cycle in optical network build to support really interconnecting these data centers for AI, whether it be for training or for inference. And again, this is whether service providers, whether cloud providers, and enterprises are really out there. And at the end of the day, you're going to need data center interconnect to interconnect all these data centers. And I think we're still at the cusp, really still early days of what AI is capable of doing. So I think it's really an exciting time to be in the networking game. And again, we'll talk about the opportunities for that. The next chart, I think, kind of double clicks on this a little more and really saying what is driving, what is driving this need for DCI. And so ultimately, to train these AI models, you have to bring the data from the enterprise. And the term in the industry is enterprises have what's called data lakes. It's their data that has to be fed into these AI training centers to create these large language models to do really anything that we do with AI. The more data you feed from those data lakes into the training model, the better the model gets, is really the opportunity. So we're going to be, we're going to continue to be seeing this because companies, again, are just starting, to really maximize what they're doing in terms of AI and building out these models. And I really like, again, another chart from Omdia, really the term they use is kind of the AI middle mile. It's that interconnect point to connect those data lakes to those AI training centers. And there's kind of two aspects to it. There's a AI access, which is likely going to be kind of 100 gig kind of port speed to kind of get you to an aggregation point. And then really what we're seeing is 400 gig to 800 gig to connect the middle mile into the core and to take us to those training centers. And interesting enough, 800 gig it is being introduced, but from an AI perspective, it's still early days. But it turns out, if you look at the way these GPU clusters are connected in these training centers, it turns out 800 gig is actually a very attractive rate for that. So I think even though probably 400 gig is probably more common today, the move to get 800 gig is really going to continue to accelerate. And that's what some of the forecasts that I have seen. So in this webinar, we're going to kind of cover all the different consumption models to build out these data center interconnect networks. And I thought this is a good, again, another great chart from Omdia that kind of shows the journey that customers have to go on in terms of building out these networks. And so if we start on the graph, the lower left, really typically when you're building on your network, you're kind of starting in what the term here is kind of your network core, your historic stronghold. This may be your campus network or your HQ, where the distances are shorter. It's easier to get fiber. You may own the fiber assets completely outright. So that's probably the easiest way, to build out your network. But as you expand, as you go further away from those historic strongholds, you now have to seek out fiber and connectivity from other providers. So the next step is to build out a private network using dark fiber, and that fiber tends to be leased. And there's a number of providers here, certainly in North America, that can offer a dark fiber asset, which you typically lease over a number of years. That you would sign an IRU maybe for 20 years. So you have dedicated access to that fiber over that time period, and you have to pay a monthly price for that. And typically, and again, scenario one we're going to show you is you building in a private network for that scenario over dark fiber. The next step up now, and as you get even further afield from your core, now you may be getting more closer to the edge, right? The growth in AI is going to tend to be at the edge of the network, to be closer to the customer so they get the best performance for AI. Those locations are probably going to be the furthest away from your core territory. And in this scenario here, that's where we're going to talk about scenario two, which is really a managed wave service, where you typically go to a service provider and they're more likely to have fiber in the location you're building out. It's a great way to expand your network for limited cost. It's mostly an OpEx model. Now, ultimately, as your network grows, a managed wave service gets expensive, and we're gonna show that a little bit later in our webinar. And the third option, which is kind of it's becoming more prevalent lately, but it's not actually new. It's actually been around for a few years, and the term is MOFN. And MOFN, not something you have with your morning coffee. It stands for a Managed Optical Fiber Network, and there's actually two variations. One is for a cloud provider, one is for an enterprise, and there's little differences. We are going to kind of look at those nuances through the webinar. And MOFN turns out to be a really nice kind of hybrid of both a managed wave and a private network for scenarios where you can't get everything you want in a private network over dark fiber. And that's why we're seeing MOFNs becoming more popular lately for exactly those reasons. So throughout this webinar, we're going to go through these three scenarios. We're going to look at it from a qualitative point of view, and then we're going to come back at the end and talk about the financial view, which is the numbers. And at the end of the day, we look at total cost of ownership, and we'll look at those comparisons of these scenarios. So two types of DCI applications, again, as we just mentioned. One is focused on just cloud DCI. So this is the one we're probably seeing the biggest growth in. This is the one, again, to extend to those AI training centers. The services tend to be pure Ethernet, and we're moving from 100 gig to much more 400 gig typically over these links. And in many cases for a hyperscaler, it can be many 400 gigs into the terabits of capacity, because that's how much you need to connect these big GPU clusters they need for AI. The second is enterprise DCI. So this is typically more to connect enterprise campuses and colo centers together. This is a mix of both Ethernet, but also storage area networking type protocols like Fiber Channel. And so there are purpose-fit products to support enterprise DCI. And in fact, you might see a mix of both, right? Because more and more enterprises are moving their traffic to the cloud. And so there may be a scenario where the enterprise has a network to connect their own internal locations, and yet they have a cloud DCI solution to connect to maybe a colo location or to the public cloud as well. So it's not just one size fits all. It may be a mix of these solutions. So now let's double click on these scenarios. So let's go through each of these and just kind of describe in a little more detail what these entail. So the first is, as I mentioned to you, kind of the first step on that DCI journey, which is really building out a private DCI network. So this is a scenario where the enterprise or cloud provider wants to build out their own dedicated network. They're going to purchase their own optical equipment. They'll get their own dedicated fiber, which they typically will lease. The network will be managed by the enterprise, and the assumption is that they have the expertise to do that. Now, however, it's gotten easier over the years for an enterprise to manage the networks. 10 years ago, an optical network was a pretty complex piece of equipment. You needed specialized staff to manage it. Today, the optical networks tend to be much more plug and play. They're deployed more like a server. So it's getting easier for the enterprise to manage these networks themselves. If I want to grow the network, you typically can do it by just adding capacity via optical pluggables, which is pretty common, and it may give you multiple 100 gigs or 400 gigs. So it's pretty easy and cost effective to grow your network, which is very attractive. And finally, the network is dedicated. So this network is not shared with anybody else. This network is just for that particular enterprise or cloud provider. So you can see in this scenario, the service provider doesn't play any role in this scenario. And so that's why many hyperscalers and cloud providers find this model very attractive, because they control everything. And as we'll show later, it's very financially attractive as well. Now, moving to the other extreme, let's look at managed waves. So this is a scenario, again, where it's a location perhaps that doesn't have as much growth, and it's a scenario where it's more difficult to get fiber. So this is basically a scenario where you're purchasing bandwidth by the client, by the 100 gig or 400 gig. The equipment and the fiber is all owned and operated by the service provider. The network is managed by the service provider, and you have to purchase it by the wave, by the 100 gig, 400 gig, and the network is shared. And we'll show a little bit more detail on that. So if you're concerned about security, if you're concerned about control, this isn't always the most preferred consumption model for a cloud provider, because they give up control. It all goes to the service provider. The benefit of this, though, is it might be quicker. It's quicker time to the market. Service provider may have the fiber available. And if your bandwidth is fairly low, it's actually quite cost effective compared to building your own. And we'll talk about that. We'll show you the details of that a little bit later. So I look at this is similar to leasing a car, right? So, give you an example today, buying an electric car. We know the technology in electric cars is going to continue to advance. So a car I buy in 5 years is probably going to be a lot better than I buy today. So leasing is very attractive in that scenario, because in 5 years, I'll get a much better car. I'll just lease it for a few years and then give it back. And perhaps in 5 years, I'll buy the best electric car at the time. And it's similar here. Optical technology continues to improve. So leasing is attractive if you think you're going to grow a lot. And if you don't think your growth is so much, and you're willing to kind of wait and see what's going to happen in future years. And so how does this network look? So basically a managed wave service, pretty simple. You have typically a dedicated optical terminal that sits at the customer prem, but it's run over a shared optical core, whether OTN or DWDM. So multiple customers will share this DWDM core. And again, it's managed solely by the service provider. And again, you're purchasing this on a per link basis on 100 gig, 400 gig versus owning the equipment. So the only thing really dedicated is typically the NID, the device that sits at the customer prem. So it's fairly simple, and like I said, but it is the quickest. It's probably the quickest time to market to get capacity. Now let's look at the third option, and this is because I mentioned to you MOFN. And so MOFN is kind of, I say, a hybrid of the two scenarios. It's a scenario where the enterprise or cloud provider wants a dedicated network, but for whatever reason, it needs to be owned and managed by the service provider. And we're going to talk about some of the reasons why that's true. But the model here is, again, optical equipment and the fiber is owned and operated by the service provider. The management is done by the service provider, although in this case, the service provider can provide typically a read-only portal to the enterprise or cloud provider so that they can see what's going on with their network, to see that their SLA is being met. And this is typically the typical reason why you know, enterprises and cloud providers like a dedicated network because they want that control. They want to be able to see what's going on in their network. The growth is typically done by the pluggable, similar to a private build. So now it's not just by the wave, but it's by the plug. So you grow by the plug, and so whatever capacity is available on that plug, that's what you could get. So you can, if you're growing pretty quickly, it's similar to a private build. And finally, the network is dedicated. So there's no sharing of the network with other customers. So if you're concerned about security, this is attractive. So this is, again, you'll see the little green triangles. I wanted to show some of the attributes that are similar to a private DCI. So even though it's managed by the service provider, it's giving you some of those same attributes as a private build, such as, again, the way it's grown, it's dedicated, and there is some management that can be done by the enterprise cloud provider. So it's a nice, again, hybrid mix of both models, why it's very attractive. Again, a kind of similar picture before. How does it look? So in this case here in the MOFN, the entire network is dedicated to this enterprise, whether it's the equipment at the customer prem and in the core of the network. That network is totally dedicated. Customer purchase it by the system, and you know, this way there's no sharing. And again, I just showed a little, you know, basically the management. There'll be a service provider portal, and then typically a read-only portal that will be given to the enterprise. So again, they won't let you make changes to the network, but at least the end customer can see what's going on with their network. And here again, pretty well security hardened, again, because it's all, you know, basically managed and dedicated to the end customer. All right, and so what I'm going to do now is I'm going to turn it over to Philip to kind of take us to double click on the MOFN option. So over to you, Philip.
Okay, great. Thank you, Mitch. And good day to everybody. So really quick, I think you've kind of gone through a little bit and listened here in regards to some of the whys already. You probably already come to some conclusions based on what Mitch has already reviewed, but there are really three main reasons why MOFN, and then there's some other minor reasons which I'll briefly touch on as well. But the three come to bandwidth demand, fiber challenges, and of course time to market. Now with bandwidth demand, you heard Mitch in the beginning there talking about as these cloud providers are deploying, you're seeing a higher bandwidth demand coming in from 100 gig to 400 gig, 800 gig in some situations, and even higher, 1.2 terabit depending on proximity to 1.6 and then future bandwidth increases further to that, right, as technology improves. But you're seeing density, the number of those 100 gig lanes, the number of those 400 gig lanes and 800 gig lanes coming down the pipeline. So the demand is increasing there from a bandwidth point of view, right? So that's increasing. So the amount of bandwidth, the amount of density that I need is growing between these cloud service providers. It's also expansion, right? Expansion, as Mitch went through right in the beginning, looking at going from subsea, then connecting regional areas, looking at new regional markets, new market segments, right? Expanding, building out new data centers. There's a demand, how many services that I'll need, of course, to build out for all of those new locations. So expansion, bandwidth, and density become a big part of that. Fiber challenges, right? As I was talking about expansion, right? Building out the expansion for those new regions, new market segments that we're looking to address with cloud service providers. You need fiber infrastructure at the end of the day. Now, with that, the basic business model of these cloud service providers or enterprise companies isn't building out fiber infrastructure. It isn't maintaining fiber infrastructure, right? That's already complex to these. It's not their basic business model. So it's very complex to these type of providers that are there, these type of cloud service providers, and what they're looking to do. It's not their basic business model. Also, looking at, as I said, expanding into these regions, it's the political, it's the laws, it's the regulations of each of these international countries that it comes with, right? Everything is very complex in different locations, especially outside of the US, and being able to build, own, lease this fiber infrastructure. So again, Very costly to build out fiber infrastructure, very costly to maintain if you don't have that expertise. Very difficult to maintain the relationships in all of these different countries and all the different laws and regulations required in these different countries to maintain that fiber infrastructure. So that's a big part of this, and looking at working with different service providers or MOFN providers to provide that type of infrastructure and maintaining that infrastructure for them. Last but not least, right, and probably one of the most important keys right now, it's speed, time, right? Time is money at the end of the day to all of these type of cloud service providers, colos, whatever they may be, building out these data centers, heavy expenses, heavy investment in building out data center infrastructure, right? Last thing that they need is long lead times in building out that type of fiber infrastructure. So speed and being able to build out or having that infrastructure ready to go as they build out massive and expensive data center build outs. The other part to that speed to keep in mind is then expansion. As I mentioned in the beginning, you're looking at bandwidth demands, you're looking at density demands increasing. So the flexibility and the time to introduce those 100 gig, 400 gig, 800 gig wavelength services that they're needing to add as this expands over time, rather than waiting for long lead times, not only the infrastructure, but also building out those particular wavelength services. Okay. Some other minor ones that I don't list here, but I think we all need to be aware of that. Control, visibility, the awareness of infrastructure. Those all become very important in looking at how is my infrastructure today, of course, in connecting my business critical network or my data center resources. So again, having awareness of the infrastructure, visibility of that infrastructure, more of even control capabilities as well. Being able to provision when I want to provision as that cloud service provider. So that's an important aspect to it. Other ones as well, as you're looking at obviously expansion of all these build outs, is just looking at obviously tooling, right? To be able to look at obviously how do I automate this infrastructure and look at the information that I've got. And last but not least, right, and I think I'll talk about this a little bit later on at the end, is this customization, is this consultation type of service, design, working with experts that know how to build out based on your requirements, your demands for that interconnectivity between these locations. And of course, then having that, as Mitch mentioned, right, having that expertise of service providers and being able to maintain that infrastructure. Again, it's not in their basic business model. Okay. Next slide, Mitch. Now, Mitch went through this a bit, right, and covered some of this already at a high level on some of the slides that he went through already. But there are really three types in general of MOFN services that are provided. There's a standard MOFN service, which is basically being able to work with all the different providers that are at those locations, the partnerships of those providers, and being able to identify the key fiber infrastructure providers that are out there. Then there's the equipment that comes with that. So it's a full solution of equipment that lights up that fiber infrastructure based on that design, based on the requirements that are needed. Now, I'm also showing here, there's three aspects to the technology that I'm showing here in this standard model, right? There's obviously the line system and being able to add that density need, and of course the amplification that you need, right? And be able to add multiple wavelengths for a customer onto a fiber infrastructure. There's a transceiver shelf, right? And the different types of density that you need for 100 gig aggregation, muxing that up, or from an exponder standpoint, with a transponder, muxponder, switch ponder, depending on the needs that they have locally at those locations, but muxing that information to coherent optics. Last but not least, what I'm showing on here is, depending on proximity, depending on what the preferences may be for a particular data center operator that's out there, or these cloud service providers, maybe it's routing, aggregating, or just simple layer 2 aggregation to switching platforms, aggregating that up from 100 gig type of client interfaces up into a coherent optic, right? So flexibility of the technologies that you would need to deliver these optical services end to end. And being able to provide that management services and dedicated fiber infrastructure. So that's a standard type of MOFN. Other types, right, may vary depending on need and depending on leverage of management capabilities, as well as infrastructure capabilities, as well as the sharing of that infrastructure that's needed. For instance, you may want to have more flexibility with a lit capacity MOFN, in which You want that flexibility in choosing the technology that's lighting it at the end, or the technology that's, of course, providing the line system capabilities between that infrastructure, right? And so we're still providing the fiber infrastructure, but with the flexibility of the different types of technology vendors that are out there to provide the services. So you're looking at still providing, in essence, similar to wavelength services, right? But with dedicated fiber infrastructure, flexibility of the technology at the ends, and obviously, looking at obviously from a capacity standpoint to be able to manage that as needed, right? And visibility to that infrastructure for that end user. Last but not least is, again, it's similar to the capacity, but in this case, we're providing a line system. So line system still giving you then that shared type of infrastructure, right? When I say shared, let me correct that, shared from a wavelength standpoint, right? Providing you more wavelength flexibility and adding these services when and if you need it. So flexibility still at the end and choosing the technologies to light up the service, but leveraging alien wavelengths across that line system, leveraging spectrum as a service across those wavelength services as well across that line system. So again, these are the three typical solutions available for MOFN typically. Next slide, please. Okay, so why ribbon then, right? And really, I know I'm listing here three, but it comes down to two areas in general, right? Software tooling and technology at the hardware level, right? From a software tooling, it's that, again, visibility that I mentioned earlier, right? So that management type of portal, management type of access, giving a customer or a data center operator, a cloud operator, visibility to that infrastructure, right? Giving them the ability to see the specific services, giving them the ability, if needed or wanted, the ability to control or provision some of the capabilities as well, right? When we talk about speed to market, as I did before. So again, visibility, correlation of that infrastructure, of course, is very important to be able to see it. Reports, any type of augmentation view, any type of performance view, that becomes important with our type of Muse application that's available. Second, with that same Muse application that's there that we can use from a tooling point of view, it's that workflow automation. Workflow automation can be leveraged in different ways, right? It could be leveraged from an instantiation standpoint to ease that deployment, ease that service creation, ease the spectrum creation across the line system, depending on what's needed. So from automation to provisioning, simplification there. From a auditing, augmentation, troubleshooting, or mop type of automation, these workflow engines become very important to a customer to ease, or low code capabilities become very easy for the operator to build these types of workflows, build the different tasks, simple drag and drop capabilities to be able to then monitor, manage, provision their different infrastructure capabilities that they've got. Last but not least is obviously at that hardware technology level, right? So from a ribbon point of view, we always stress flexibility, versatility is always a big part of it. But again, as I mentioned in the beginning, density, performance are very important here. And having the ability to, of course, to provide that 400 gig density, upgradable to 800 gig, already available, ready to go with 800 gig when necessary on the same card technology. That becomes very important. Of course, the density is already there in these platforms to be able to add when needed as that density grows and the demand for that increases, and adding in the pluggables on that infrastructure, ready to go on these type of platforms. Performance, right? And performance from a distance point of view. Having the technology, best in the market type of technology to provide that performance from a distance standpoint and bandwidth capacity already inherent in the types of DSPs that we're using. So those become a big part of it from a tooling point of view, to give that visibility, to give that control to that cloud provider, to that operator, to that enterprise customer, giving simplified tools with low code type of automation, workflow engines to make it easy for an operator, or letting us build that for you, and giving the tool sets that are there to quickly instantiate or simply instantiate the right way every time based on that consultation, and be able to monitor, of course, that infrastructure as well, and putting in the automation or augmentation or auditing tools that are there for you, of course, and any type of reporting. And last but not least, that density capability that I mentioned before, and of course, the density with that performance for a distance point of view as well. Next. Okay, so I mentioned obviously from a software tooling point of view, that capability of being able to visualize my infrastructure, right, as an operator. Again, this isn't the level of expertise of these operators, but they want some level of visibility and control. Now, there are two parts to that that become very important, visibility and control aspect, and leveraging this type of tooling. It's the multi-tenancy capability and network slicing. So from a multi-tenancy point of view, we want to be able to provide, obviously, a tenant, create that particular tenant for that operator, but dedicate resources, hardware resources, logical resources to that particular tenant. Give the tenant the ability to create their own users as well, and give them the authorization to do certain capabilities, depending on what they're looking to do. Certain capabilities to build their own automation tools, as I mentioned earlier. All right, so that capability is there, but it starts with dedicating a physical and logical resources to a tenant. So when they log in through that access portal, they can see their dedicated infrastructure. They can see the dedicated services relevant to their implementation. They can see those logical services across that, and of course, then leverage that tooling capability to augment, add as needed. So multi-tenancy becomes critical in that aspect from a Muse point of view. The other part, and maybe we can go to the next slide here, is that slicing or network slicing, right? Network slicing is nothing new. It's something that became very common in terminology in 5G types of infrastructure, right? But slicing's been around for a long time. Slicing, again, is that dedication, as I mentioned moments ago, of resources, but dedication of these types of resources to a particular service, to a particular tenant. So you're slicing an infrastructure and allocating those resources, hard and soft resources, as mentioned. Some of those could be spectrum, right? As I mentioned earlier, with regards to the different types of MOFN services provided. This is also another option for those providers or service providers that don't necessarily want to provide a dedicated physical fiber to a particular cloud service provider. This gives them at least a way of leveraging shared spectrum or dedicating spectrum to these cloud providers as well, right? They can give them a particular spectrum bandwidth of need, in which then the operator has the flexibility in adding the different wavelength services across that dedicated spectrum. But that takes, again, allocating those resources, in this case, to a particular tenant so they can visualize that infrastructure, but these dedicated spectrum resources across their infrastructure as well. Right, that overlay capability and visualizing each of these layers from that logical service all the way down to the physical infrastructure being leveraged. Okay, so allocating the resources in this case to that particular tenant becomes critical. Okay, next. So I think we could maybe play this out a little bit as we go through, right, on a different slide, on this slide, Mitch. Maybe put all three options, but when we look at this, we can go down each one of these, right? So from comparing the different options that Mitch has gone through before on managed wave versus private build versus MOFN, visibility of my network. As already introduced before, with a managed wavelength, you're paying for that wavelength, meaning you don't have visibility awareness of that shared infrastructure that a service provider is offering. Not only you, but other operators at each end. So lack of visibility, awareness of that infrastructure. Private build, of course, it's dedicated infrastructure, leased infrastructure. You have the equipment at each end. You have the better awareness of that infrastructure. Same thing with MOFN, right? You have, in a way, a best of the both worlds here. You have obviously the view, you have infrastructure, you have dedicated infrastructure, you have accessibility to tooling that can give you awareness, visibility to that infrastructure, and of course, then the possibility of control of that same infrastructure. CapEx, right? As we looked at it before, CapEx, yes, you're paying per wavelength, so less of a CapEx hit, of course, up front. You're paying per service. All right, so as we look at the other options, there's a little bit of a hit, a bigger hit in private build, right? When you're looking at everything that I need to add, including that fiber infrastructure that I'm leasing, and all the equipment that's necessary right from the beginning. So you have a bigger hit on the private build aspect of it. With regards to MOFN, it's a little bit of blended at this point, right? Now we're talking about blending. Yes, we have more of a CapEx hit in the beginning of adding the infrastructure, but you have less of course, of an increment later on. And Mitch will go through some of the financials of this towards the end of the presentation. OpEx. So, and we'll cover this again, but OpEx, as you continue to add these wavelength services, you'll see obviously the total cost of this starts to increment pretty high. And as we mentioned before, this density needs that are coming in, you're just adding on top of each of these wavelength services. So the price and the cost over time becomes very high in a managed type of wave service. With regards to private or MOFN, better OpEx overall in the long term, right? Because obviously the infrastructure is there. You have the leased infrastructure. You have the capability, of course, of adding, right? You have the ability to add further density to that platform. You have more of that critical fiber infrastructure. Now you can add in the resources or wavelengths as needed, right? So your cost structure is much better in both a private and a MOFN type of implementation. Easy to expand, right, to new locations. So, of course, as you look at a managed wave, that's being handled for you, right? So, yes, it's easy to handle it because it's being done by the particular service provider. They're building out the entire net infrastructure. Whereas a private build, it's more on you, right? It's more on the cloud provider than to do that. So there's more work that's necessary for that particular cloud provider. MOFN, again, as I mentioned, yes, there's a control aspect. Yes, you have the ability to do it as you want, right? That is an option that can be provided, but that can be done for you. So the ease of expanding becomes simpler, right? You have that hardware technology that's there that allows you to add the density needs, as you allow the performance needs that you need for the distances that you may have, but just to continue to add to it, right? You already have that necessary fiber infrastructure. Now you're just adding the wavelength services on top of that as needed, when you need it. Scale, right? As we talked about, right? Scale is a big factor here, and looking at it continuously throughout this messaging. I can scale further based on that technology that's chosen, right? With a MOFN and a private network, the choice is on you to be able to add in the technology that can support the scaling needs that you have in that consultation service. You can maybe envision that you're going to be adding these type of wavelengths or channels that you're going to need over time. You can make then the relevant decisions of what that infrastructure will be that allows you to scale quickly, right, and be able to deliver those service infrastructure. So higher level of scale versus an unknown from a service provider of what's been made available to the end users that are leveraging that shared infrastructure. Last but not least, but very critical to all these discussions, is the ops aspect of it, right? Operational support, which comes into that OpEx cost modeling as well, right? But that expertise, as I said a while ago already in the discussion, it's not the natural business model of a cloud service provider or a cloud provider in general to maintain, manage fiber infrastructure, maintain and manage these services across there. It's not their business model, nor do they typically have that expertise. So there is a heavier cost from a private build standpoint in which you're having to take that on versus a managed wave or a MOFN that is incorporated, right? The maintenance of it, the management, the upgrade capability, right, become options for you, right? In regards to how do it's taken off your hands from an operator point of view, and it's put onto the MOFN service provider or a managed wavelength service provider. They're maintaining it. One thing to keep in mind when I mentioned upgrades and some changes to infrastructure for performance needs, remember, from a managed wave, it's a shared infrastructure. So any type of upgrade capability, it's going to be time, right, to do that, to allocate the time to upgrade a particular shared infrastructure because of the impact on many other operators that are leveraging that shared infrastructure. That's not the case for a MOFN type of service, all right? A MOFN type of services, this is a dedicated infrastructure and dedicated technology for that cloud operator, meaning when it's time, whether it's end of life on a particular software or new feature sets or new capacity, new hardware, the upgrade path is faster to get to, right? There's not a longer wait. It's a quicker turn. It's on you then if you want to go down that path now versus at a later point. So big option there with regards to from an operations point of view, it's that upgradability. It's the skill set needed to maintain this infrastructure, of course, that's being provided by a MOFN type of service. Okay. Next slide, and I believe that might be back to you, Mitch.
Perfect. Thanks, Philippe. So I'm going to take us through the last few charts of our webinar today, and I'm going to talk. This one is again to show all the different channels to market for a customer to build a DCI, right? So we have our two options: our enterprise DCI and our high density cloud DCI. And there's four kind of different channels to market. One is basically enterprise direct. The enterprise, and typically it's a big enterprise. We have a lot of experience in the utility market. You know, they're in many cases build networks as big as any service provider. So they basically can procure the equipment and purchase it themselves and deploy it themselves. May go through a system integrator. For customers that need support on, installation and management, obviously through the service provider. And again, a data center operator typically also could go direct. Certainly some of the larger hyperscalers and cloud providers, again, are big enough that they have enough in-house staff that they can go and build these networks themselves. So you can see all the different scenarios. So the ones that we've talked about, one could be a private network, both enterprise or data center, basically build it themselves. Could be a combination of MOFN or private network or MOFN and managed wave through the service provider. So lots of different ways, again, to skin the cat here. And it's really to look at the best solution to meet a customer's need based on the attributes that Philip had gone through. So we've talked about the qualitative aspects of these three options, but let's talk about the financials. Let's talk about the dollars and cents, right? Which is pretty important at the end of the day. And so what we've done is built out some financial models comparing these three options. And these are all the components that we built into these models. And some of you may or may not be familiar with. Some of these are terms that come from that service providers typically use, but I'll kind of go through these. I've separated this. Everything in orange is kind of a CapEx or upfront cost, and everything in kind of the purplish is an OpEx cost, right? So managed wave on the left, pretty simple. You pay some kind of non-recurrent, what they call a non-recurring cost. It's an NRC is the term used by service providers. Fairly nominal cost. It may be like equivalent to like a month's worth of the monthly recurring costs. Then you get into your monthly recurring cost. Very simple. Again, it's by the wave, so by the 100 gig, by the 400 gig. And then there may be an option for protected wave, right? So it's really, really simple, and it scales linearly. The more you buy, the price goes up. Private DCI, very similar. Those of you who have built on an optical network know these are the components that you deal with. You have to purchase the equipment. You have to get it installed. You have to allocate some cost to op support. There's a cost to leasing dark fiber, typically $1 per mile per month. It will vary by the market you're in. If you're in a very competitive market like a New York City, that will be cheaper. But if you're in a smaller regional market, that's going to be more expensive. There may be colo costs if your network has to go through colo. And then the typical annual software upgrades, spares, warranty, all the things associated with private DCI. And then a MOFN, again, is a mix of the both. It looks like a managed wave. There's going to be an NRC, but it's going to be much more expensive than you get with a managed wave, because now the MOFN is basically an entire dedicated network. Is the service provider basically has to go and purchase that and install it up front. So you, the end customer, are going to have to pay some higher upfront costs to reflect that. And then your MRC is by the system rather than by the wave. So you're paying, again, the service provider is going to want to recover that capital cost they've laid out. And that will typically be higher. And then as you grow the network, there'll be, again, additional MRC associated with those pluggables. So you're going to get more bandwidth, but you're going to pay a higher MRC for that. And then there, again, may be options for survivability depending on, how survivable, diverse paths you want to do. So those are all the components we built into the model. Looking at this, so let's look at, we wanted to just, again, make this simple. So let's start off with just comparing managed wave to private bill first. So the managed wave in blue, the private bill in kind of pink here. You can see here on the left, we looked at the cash flows by year. You can see in year one, a private bill is much more expensive than a managed wave because, again, of all that extra capital cost that the cloud provider or enterprise is laying out to build out the network. But in the private bill, the ongoing OpEx cost is flat and much lower, right? Because they're paying, now it's not zero, right? Some people may perceive, oh, I'm building my own network, I'm putting in all that upfront capital. And as I mentioned to you, a lot of components of OpEx there, including dark fiber being a big one. So it's lower, but not zero. So it's ongoing and it's fairly flat. On the managed wave, you can see each year it's growing some more, right? And the assumption here is each year the customer's adding another 100 gig wave, right? So they're growing at a kind of a consistent rate. So by year 5, you could see the annual cost of OpEx is 5 times that of year 1, right? So it gets pretty expensive. On the right, you can see the cumulative cost, the sum of all these bar costs. So you can see here, it becomes very obvious. In the first 2 years, when your growth is low, the managed wave is the cheapest, right? And no surprise, right? Because it's you're only paying by the wave. The private bill is going to be more expensive because of that upfront capital cost. But over time, as you grow, the managed wave crosses over the private bill at between 200 and 300 gig waves. And you can see by year 5, it gets to be much more expensive. And the private bill is much more cost effective. So you can see anyone who, if you're a customer or yourself, see yourself growing past that third 100 gig, private bill is probably going to be the most attractive option, right? It looks attractive. Managed wave is attractive in the early years, but much more expensive in the latter years. And there may be a hybrid of approach. Some sites, a private bill makes sense, and other sites, a managed wave is more cost effective because those sites may never grow to beyond 300 gigs. So don't think of this as one size has to fit all. It may be a combination of these options. And by the way, just the bar chart, this was based on a US pricing model. Certainly if we did this analysis in Europe, it may look different, but the shape of the curve, I think is going to be similar. Now let's add MOFN to this, right? So MOFN now again brings in a model where we basically, again, it looks like a private bill, but it's managed by the service provider. And so basically you can see here, bar charts is a little difficult. I know it's a little bit busy, but if you look on the right, you can see the MOFN kind of an orange curve is similar to the private bill, but is higher, right? Because that reflects the cost of the service provider charging their fee for the, for the leased fiber, for managing the network, and so on. So it's still much more cost effective than a managed wave, certainly when you get to years 4 and 5, but it's going to be more expensive than a private bill. And so it kind of sits in the middle. So that's why for many customers, a private bill is obviously the most cost effective and your ideal option. But if you can't get all those attributes, you can't get leased fiber, for example, then MOFN becomes a very attractive option. So one thing we can do, Ribbon, we built these models to be very flexible. So that's something, if you're looking at these different scenarios, we can model this with you. We can put in your costs into here to reflect this and really give you a set of curves to reflect your situation, so you can make an educated decision from a financial point of view of which of these consumption model makes the sense for you. This chart, we actually shared this in the last webinar, but I brought it back again. I'll just go over it quickly. It's a nice example of a mix of both a private and managed wave. So this was our scenario. A data center operator wanted to connect a data center about 65 miles east of Atlanta. They went out and they built their own private DCI using their own dark fiber, purchased equipment themselves. So that's very typical, but they wanted a backup resilient link. In this case here, it was much more difficult to get this resilient, diverse fiber. So they went to a service provider that had that fiber, and they were able to get a managed service for a 100 gig managed wave. So it's a very good example of kind of this hybrid approach where a private DCI makes sense for the most direct link, and a managed wave was good for the backup link. And I think you're going to see this very common in a lot of scenarios. All right, I'm going to turn it back to Philippe just to close us out on kind of their solutions. Over to you, Philippe.
Okay, great. Thank you. So quick, I talked about obviously the technology there a little while ago with regards to the versatility, capacity demands, performance demands that are necessary, and just flexibility of needs, right? Depending on what is a preference on some of these implementations, lighting at each end and having the capability to grow as needed. So we're going to provide obviously some of the collateral on the site. Of course, there will be links that will be available as well to access some of this collateral. But I'm just introducing a few of those just so we can talk about the two different use cases as Mitch introduced, right? From a cloud or high density DCI type of implementation to, of course, an enterprise DCI. I'll start on the right, but with an enterprise DCI, to me, it's not as necessarily dense as a cloud service provider, but they still want flexibility, but as well as the ability to still provide 10 gig lower rate, so low to high water type of aggregation capabilities, as well as security capabilities with encryption and obviously SAN support, right? So fiber channel support, depending on the locations, InfiniBand, et cetera, right? Being able to support those storage array networks. So again, flexibility needed. So we take advantage of the 9600, which is a very flexible platform, gives us the ability to provide the performance capabilities that we need, right, if necessary, with regards to density or capacity, but provides also that LR4, the InfiniBand fiber channel capabilities for SAN infrastructure, provides encryption capabilities. So very versatile platform for those type of build outs for enterprise customers. On the high density side, there are two main platforms that I'm touching on here, right? One, depending on obviously the preference of the particular cloud provider and looking at how they're simplifying their aggregation, whether at a layer 2 or an IP point of view, there are platforms there that are newly introduced, Neptune 2714. It's a 14.2 terabit platform, provides obviously the capability to add multiple, of course, of QCP-DD for dense 400 gig deployments, or flexibility, as I mentioned earlier, with that from an enterprise point of view of lower rates, right? 25 gig SFP capability as well for lower rate aggregation, and then back up into leveraging those coherent optics, right? Uplinks. So again, it's an IP over DWDM solution, depending on technology preference by the cloud operator. But to meet those also density needs that I talked about, as well as performance needs for these cloud service providers that are expanding the amount of 100 gig, 400 gig lanes that they're looking to implement, as well as, of course, having those high capacities over further distances within the metro or wherever they're expanding to, then a 9408 type of platform introduces that. It's a dedicated transceiver shelf, gives the density of hardware that's 400 gig ready from a QCP-DD standpoint, but also 800 gig ready as maturity of those plugins become more and more available in the market, right? From a not only client side, but line side from a coherent optic standpoint. So heavy, dense capability up to 25.6 terabit per 2RU chassis with a 9408. So again, density there, availability at the particular endpoints, depending on what their needs are, but also then performance with the latest 5 nanometer DSPs available that can provide rates of up to 1.2, and further as the technology improves, 1.2 terabit today for distances of 120 kilometers for 1.2 to 3,000 kilometers for 400 gig, or regional distances of 800 gig or 1,500 kilometers. So performance, density with the 9408 platform, and continuing to evolve, obviously, the pluggable evolution that's being introduced for each of these platforms. So again, flexibility of technologies that are available that gives that capacity capability that a customer may need, or the low aggregation that an enterprise customer may need. So again, different types of use cases, but there are different platforms that can meet that need. And this is what we would go through in that customization design discussion with an operator. Next slide. So again, just to kind of complete this, right? As I said, that technology will be there, but just to kind of complete this, pull this all together a little bit here at the end. From a technology point of view, I talked about, obviously, from a full layer stack point of view, that capability is there. There's not a particular preference that we're positioning, but we have the availability of layer 1 to layer 3 capabilities that are there in our technology set. Encryption, so security demands that are there, not only obviously layer 1, but all the way up the stack as well. Automation, those toolkits that I talked about. So automation capabilities to simplify this for you, for those operators, to be able to create these services with that type of workflow engine and the low code capability that's there to simplify that creation of these services, all inherent in our Muse application. And ecosystem integration, right? So not only adaptation in our software tooling, but also adaptation not only southbound to that technology of our own technology, but any other vendor technology as well, but also to any tooling that operators may have. So northbound, right? So integration ecosystem of our infrastructure and our tooling around that. Technology, again, I'll keep hitting it, 400 gig, 800 gig ready from a QCP/DD standpoint, high density, low power. When you look at the total consumption there of power for all the 400 gig, 800 gig lanes that are supported, best in the market, in my opinion. And last but not least, an ecosystem of partners, right? So I talked about, obviously, the fiber infrastructure partners that are there that would be necessary, partnerships there for design, staging capabilities, right? So value add functions, good ecosystem of partnerships that are available at Ribbon beyond just the technology, the tooling that we bring, and of course the services that we can bring on top of that during any of these designs discussions and trying to meet the needs of the different operators. So full support, full ecosystem, full technology, and of course increased evolution of our portfolio as we continue on. Just a quick little wrap up there. So again, thank you all for the time. Mitch, I don't know if there's any final words that you may want to say, but I appreciate any of the time that you've given to us here.
No, thanks a lot, Philip. And I think we covered a lot of ground. Hopefully we gave you some really good insights on the different consumption models for DCI and the both qualitative and financial. And I know we just have a couple of minutes here. I don't know, Lance, any questions from the chat?
Yeah, thanks, Mitch. Yeah, we do have a few, and yeah, with respect to time, we'll kind of run through them kind of quickly if you don't mind. But a couple good questions. You know, the first, MOFN, is that like a new concept? Was a question that came in. Is MOFN a new concept?
So the name, I think, is more new, but the concept is not totally new. It has been around. You know, I've been in this industry 20 plus years, and so the concept of a private managed network is certainly something I've seen service providers offer. I think it's becoming more prevalent lately because I think the cloud providers are kind of running out of ways to build networks themselves, even though that's their preference. They really need, you know, they're basically entering into regions and territories where it's more difficult to get dark fiber, and so they have to rely on the service providers to deliver that network. So I think that's why we're seeing it more common, and we're seeing, you know, there are many players in the industry that you know, a high percentage of their deployments are that MOFN. So I think we're going to be seeing more and more of it certainly lately, but overall, no, it's not a totally new term.
All right, great. Thanks, Mitch. Next question. You talked about all the different, you know, deployment options and models. How can a customer decide?
So hopefully we've given you the tools today. We shared with you, we built a financial model that really kind of, you know, if you remember that chart, it showed all the different components of building at a DCI. And we looked at those three options. So that's certainly something we can work with a customer. We kind of have a generic model, but we're happy to work with a customer and basically plug in your numbers, right? So you can see exactly what, you know, depending on the market you're in, you know, what are you paying for a managed service? What was it cost for you to procure equipment, and then what it would cost to get a MOFN? And so you can, the curves that we shared with you, we can update that for your scenario, and that actually will tell you precisely, you know, exactly what situation, what's going to be the best fit. And we can actually look again at the concept of a hybrid, right? To say, let's look at all your sites, right? Some sites, a private bill or MOFN may make sense. Others, a managed service may make sense. And we can help you again look at what's that best combination to best meet your needs. So I think we have all, you know, we have the tools in the toolkit here, both technically and financially. And that's feel free to come to us, our sales team, and we can really educate you on that option.
Mitch, I just to add to that, I think you hit it very well there. But I think I mentioned it earlier, right? But briefly, but it's that consultation service aspect of it, right? When we get into the discussion, identifying the needs, identifying the requirements, and then going through the different options that are there that we talked about, the types of services, and understanding on both sides what's the best fit for these locations or what's the best fit for these other locations. It may be different, as you said earlier, hybrid type of implementations, but that's at the consultation point, right? That's where we can go over this and look at the numbers and what makes the most sense and what makes the most sense from a technology, capacity, density, etc. Right?
Exactly. So and we have a lot of partners that we can recommend the right partners to work with you, right? To whether it's service provider, whether it's a system integrator, to meet your needs. So absolutely.
Great. One more. How can a service provider offer MOFN, but when they don't want to give up their valuable fiber to a single customer, how can they offer that?
So I think, Philip, you had a great chart on this. The concept, which again I think is becoming more common, is the concept of spectrum service. So within a fiber, you can actually create a virtual fiber, meaning you can sell optical channels versus actually selling the physical optical plant. And that lets you basically offer multiple customers over that same, because you may have some routes where that fiber is really valuable. You may not have enough strands to be able to say, I want to sell it, dedicate one customer just to that strand of fiber. And so spectrum really becomes attractive. And I don't know, Philip, if you want to add to that.
No, that's spot on. I think at the end of the day, as I said earlier, this is more of a granular dedication of logical resources to that infrastructure, right? So obviously the capability to provide dedicated spectrum across there, dedicating to that tenant, but also the flexibility to still leverage that fiber infrastructure for others, right? Dedicating that resource from a spectrum point of view to other operators if necessary on those critical fiber paths, as you mentioned, right? But it's just a lower granularity of dedicating resources.
Exactly. Well, I know we're over just over the top of the hour, so I guess maybe let's turn over to you, Lance, to wrap it up.
Yeah, absolutely. Well, thank everybody for attending today. Thanks, Philippe and Mitch, for the content. As usual, expect an email follow-up from us later today with a link to the replay in case you want to go back and review anything. There'll also be a copy of the slides later on this afternoon and ways to reach out to us there as well, right? Reply to that email. Find us at ribbоncommunications.com. We're always here to help with any of your questions. And we look forward to seeing you on our next webinar on this topic or the same data center interconnect topic, likely towards the end of the summer. So look out for that invite soon. Thank you all.
Thank you.
Thanks so much. Have a great day.